In this lesson, we will solve and graph inequalities. Solving an inequality is just like solving an equation. We follow the exact same steps. We want to continue to keep both sides equal at all times. The difference is that in our answer, we're going to have an inequality symbol instead of just an equal sign. So let's look at example number 1. 4x plus negative 8 is greater than 12. We need to get the constants on one side of the inequality sign, and we want the variables on one side of the inequality sign. If you look at number 1, we need to move the constant of negative 8 over to the right side. So let's add 8 to both sides. Once we've added 8 to both sides, we now have 4x is greater than 20. Again, we're going to solve just like an equation, so we're going to divide by 4 on both sides. And we're going to come out with an answer that says that x is greater than 5. Again, all the steps are the same as an equation, but in the end, instead of me figuring out that x equals 5, I found out that x is greater than 5. What that means is that x could be any possible number as long as it's bigger than 5. So x could be 6, x could be 10, x could be 21, x could be 342. As long as the number is greater than 5, it's a possibility for x. Now, when we solve an inequality, we also graph them. We're going to talk about graphing tomorrow, so we're just going to go on to example 2. N divided by 2 plus 12 is less than or equal to negative 4. Again, just like an equation, we need a variable side and a constant side. I notice that all my variables are already on the left, so let's move our constants to the right. Let's take away 12, and let's take away 12. That leaves me with n divided by 2 is less than or equal to negative 16. Now, how do we get n by itself? Well, we have to think, what's the opposite of dividing by 2? It's multiplying by 2. So let's multiply by 2 on both sides. Our 2's on the left cancel one another out, leaving us with n is less than or equal to negative 32. That means that n could be any number as long as it is less than negative 32, or in this case, n could be exactly negative 32. Let's look at one additional example. Let's solve, and I want us to leave it written as it is. We'll talk about another way to solve it in just a minute, but let's solve it as it's written. So let's take away 3 on both sides. Okay, that'll give us negative 15 is greater than 5n. Okay, again, just like an equation, let's get n by itself, so let's divide by 5 on both sides. That gives us an answer that says negative 3 is greater than n. Negative 3 is greater than n. What are numbers that negative 3 is greater than? Negative 3 is greater than negative 7. Negative 3 is greater than negative 10. Negative 3 is bigger than negative 22. So n could be said to be anything smaller than negative 3. Okay, this inequality says negative 3 is greater than n, but we could also think about that as n is really less than negative 3. Let's look at the inequality that we started with. Some of you, when we solved equations, like the idea of changing the order. You would, if this was an equation, many of you would like to put the 5n plus 3 first, and you'd like to put the negative 12 on the other side. You can do that with an inequality, but it is crucial that if you flip the sides, you have to flip the inequality sign. So we would change this original sign from a greater than symbol to a less than symbol. Now, let's solve it that way. Let's take away 3 on both sides. That will leave us with 5n is less than negative 15. To get n by itself, we're going to divide by 5, and we come up with an answer of n is less than negative 3. Let's think for a minute. What numbers are smaller than negative 3? Well, the further away from 0, the smaller we get. So n could be things like negative 7, like negative 10, like negative 22. So notice that these two answers mean the same thing. They look different because the inequality sign is different, but they communicate the same thing. Saying that n is less than -3 is the very same thing as saying -3 is bigger than n. Now, as we move on and we look at the next concept, it is crucial that you stop and you listen very carefully to this caution. If you need to replay it several times to get it, go ahead and do that. When you solve an inequality, if in the very last step of the inequality you find yourself multiplying or dividing by a negative number, then you're going to flip the inequality symbol. Again, this rule only applies to the very last step of a problem. If in that very last step you find yourself multiplying or dividing by a negative number, then you're going to flip your inequality sign. Let's look at an example of what I mean by that. Example 4 here. It says -3x plus -2 is greater than 10. I cannot look at this right now and decide if I'm going to flip the inequality symbol. I can decide in the very last step. So let's go ahead and solve. Let's get our constants on the same side. Let's add a +2 here and a +2 here. That gives me -3x is greater than 12. Now, in order to get x by itself, think through what will we have to do. We're going to have to divide by a -3. This is where that rule applies. We're in the last step of the problem, and we have to divide by a -3 in order to get x by itself. This is where the special rule comes in. We say x is not greater than anymore, but x is less than -4. Again, the reason we flipped our sign was because in order to get x by itself, we are going to divide by a -3. Anytime in that last step we divide and it's a negative number, we're going to flip our sign. Let's look at another example, number 5. That one says x divided by -4 minus 8 is greater than or equal to -16. Let's get our constants together. Let's add 8 to both sides. That gives me an inequality that says x divided by -4 is greater than or equal to -8. Now let's think about how we're going to solve this. How will we get x by itself? Well, I know the opposite of dividing by -4 is to multiply by -4. So let's multiply by -4 on both sides. Again, here we are. We're in our last step. We're trying to get x by itself. That requires us multiplying by a negative number. So this is going to be one of those inequalities where we're going to flip our sign. We're going to change it from greater than or equal to less than or equal. Now let's work it out. Our -4's cancel each other out, leaving us with x is less than or equal to 32. So again, that special rule says when I'm at the very, very last step of the problem, if I find myself trying to get x by itself, and I have to multiply by a negative number to get x by itself, or I have to divide by a negative number to get x by itself, we're going to change the direction of the inequality sign. Let's look at one additional example together. In this inequality, we have variables on both sides of the inequality symbol, and we have constants on each side. Remember, we have a choice here to make. I am going to choose to put all of my variables on the left, and I'm going to choose to put my constants on the right. You may choose to work the other direction if you'd like. All right, so to get my variables on the left, I'm going to add a positive 9x here and add a positive 9x here. That gives me positive 6x plus -2 is greater than 10. In order to get my constants on the right-hand side, I'm going to add a positive 2 here and add a positive 2 here. My inequality is now 6x, is greater than 12. To get x by itself, we're going to divide by 6. In this last step, when we get x by itself, are we multiplying or dividing by a negative number? No. So that means my inequality symbol will stay, so it's x is greater than 2. Now, let's just look for a minute. Let's say that you wanted to solve this inequality, and let's say that you chose to put your variables on the left and your constants on the right. Let's look at how that would change our problem slightly. Okay, we're going to make the left-hand side for constants this time, and we're going to make the right-hand side for variables. Okay, so in order to do that, let's add 3x on both sides. Negative 3x plus 3x is 0. That leaves us with negative 2 is greater than 10 plus, let's go ahead with a minus sign here. Negative 9 plus 3x is negative 6x, so let's write negative 6x. Now, to get all the constants on the left, we need to take away 10 on both sides. We're going to be left with negative 12 is greater than negative 6x. In order to get x by itself here in this last step, what are we going to have to do? We're going to have to divide by negative 6. Because I'm dividing by a negative number, I'm going to flip that inequality sign. So I'm going to have an answer that says 2 is less than x. Let's think about these two answers. Do they communicate the same thing? X is greater than 2. Think of a number greater than 2. I think of 5, 10, 15. Those are all possibilities for x. Now let's look at the other answer. 2 is less than x. Give me a number that 2 is less than. Is 2 less than 5? Yes. Is 2 less than 10? Yes. Is 2 less than 15? Yes. So you notice that these two answers communicate the very same thing. We solve the inequality slightly different in each of those examples. However, our answer communicates the very same message. Now, I just want you to check your understanding of that rule. If this was the very last step of an inequality, would you flip the sign to solve it? Pause the video, and I want you simply to write yes or no by each of the 4 examples below. If this was the very last step, would you have to flip the sign, yes or no? Pause your video now and try those. So in example 1, to get x by itself, I would have to divide by a positive 3. So no, I would not flip the sign. On the side where the x is, to get x by itself, I did not have to divide by a negative number, so I do not flip the sign. Look at example B. This is supposed to be y divided by negative 4. In order to get y by itself, we would multiply by negative 4 on both sides. Since on the side with a variable, I am multiplying by negative 4, this would be an example of when I would flip the sign. Letter C. What do we do to get x by itself? We're going to divide by negative 5. So would I flip the sign? Yes. On the side where the x is, I had to divide by something negative, so I flipped my sign. Look at example D. N divided by 9 is less than 3. To get n by itself, the opposite of dividing by 9 is to multiply. Would I flip the sign in this one? No. In order to get n by itself, I did not have to divide by something negative.